Hello everyone, let's look at Leetcode question 198, House Robber. You are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed, and the only thing stopping you from robbing every single house is that the adjacent houses have security systems connected, and they will automatically contact police if two houses are broken into in the same night, which are adjacent. Given the integer array nums representing the amount of money at each house, return the maximum amount of money that you can rob tonight without alerting police. Before looking at the examples, let's look at the constraints. So the number of houses along the street is somewhere between 1 and 100. And the money stashed at each house is between 0 and 400. Okay, to solve this problem, we first want to define two variables, previous one and previous two. These variables will serve for us as paths between all non-adjacent houses that yield for us the maximum amount of money robbed. Next, we want to loop through every single house and define the new maximum path between non-adjacent houses. Then we define previous two as the old maximum, previous one, and previous one as the new maximum path. We go through every single house and find the maximum path to return previous one, the maximum amount of money robbed. Alright, so in this first example we start out at house 1 because the maximum between prev 1, 0, and prev 2 plus num, 0 plus 1, is 1. Therefore prev 2 becomes 0 and prev 1 becomes dp 1. The path so far is just one house, and we have 3 more houses to explore, but so far the maximum is 1. Prev 1 equals 1. The next house is value 2, so we find the maximum between prev 1, which was 1, and prev 2 plus num, which was 0, plus 2. Prev 2 equals prev 1, so this means that prev 2 becomes the old value, 1, and prev 1 becomes the new value, 2. Next, we go to the house number 3 and update the values. We can now see that there's a path 1, 3. The maximum was prev 1, which was 2, and prev 2 plus num, which is 1 plus 3, that's 4. Prev 1 becomes 2, and prev 1 becomes 4. This is so far the maximum. And we go to the last value, but this will not change the maximum. This will just change previous 2's value because the maximum of prev 1 is the current and previous value. Therefore, we return 4, and previous 2 is also 4, but we don't care about this. But we can see that it would matter if we had other values, as we will show in other examples, where values are greater and non-adjacent, so we have to keep track of these. Okay, this example is a little more interesting and complicated, but let's go through it step by step. First house to be robbed is house number 1. It has $2,000, let's say. So dp is max between 0 or 0 plus 2. So dp equals 2. Therefore, previous 2 is the old maximum value of 0, and previous 1 is the current max, so 2. Previous 1 is 2. Next house, please. They have $700,000 at this house, so we go looping through it. dp equals maximum between previous 1, which is 2, and previous 2 plus num, which is 0, plus 7. That's 7, so dp becomes 7. Previous 2 is the previous max now, so 2. Previous 1 is the current max, 7. Alright, next house is number 3 with $9 billion. So we loop through all these houses and we arrive at house 9. So previous one is 7. That was the current max. Now previous 2 plus num is 2 plus 9, 11. We found a new max. Previous 2 is old max of 7. Prev 1 is new max of 11. Alright, next house to rob has only $3, so we loop to it and don't care about it. Maximum between previous 1, which is 2, 9, 11, or previous 2 plus num, 7 plus 3, that's 10. 10 or 11, 11 takes the cake. It's still going to be 11. Previous one does not change. However, previous 2 is defined as the old max, which is also the current max now. So 11 becomes the maximum, remains the same. Next house is 4. This will be sufficient. So maximum then is 11, or 11 plus 4. That is 15. dp equals 15. Previous 2 is now 11. Previous 1 is now 15. So far we have a maximum of 15 to rob from. Non-adjacent. Finally, this is where it gets interesting. The last house has 6. So we find the maximum between the previous, which was 2, 9, 4. That is 11 plus 4, 15. Or previous 2 plus nums. Remember that was 2, 9. 11, so 2, 9, 6. That is 17. That is greater than 15. So previous one has a new value of 17, and then previous 2 has the old max of 15. Therefore, we return previous one as 17. This is the maximum amount of money. All right, now let's look at the solution. Okay, let's check the solution, and it works. Very good. The time complexity of this solution is O of n, where n is the length of the input list nums. This is because we iterate through the list once to calculate the maximum amount that can be robbed. And so the space complexity is O of 1, because we only use a constant amount of extra space to store the previous 2 maximum amounts. That's it for this video. Thank you for watching.